Let's try another systems problem, and this here is the classic wind resistance or water resistance type question. Try to recognize it. So what we have here is a jet takes 4 hours to travel 200 kilometers against the head wind. On the return trip, the jet takes 2.5 hours to travel with the same wind, now called a tailwind. So the tailwind makes you faster, the headwind blows in your face and slows you down. Determine the speed of the wind. So the key formula to memorize is that distance equals velocity times time. This is like your speed. And plug in your known values. We know the distance here is 200 kilometers. So this is going to be 200 kilometers when it go is equals to, this here is the velocity. And the velocity is not given. However, we know the velocity is going to be, with a headwind, is going to be slowed down. So we're going to go minus w. This here is the speed as a result of the headwind. The time here is given is 4 hours times 4. So this first formula happens to be a line, and this is with the headwind. On the return trip, so we're also going 200 kilometers, we are going to take 2.5 hours. That's the time. And what we're going to have here is a tailwind. So whatever the regular velocity of the jet here is going to be actually faster. How much faster? It's going to be faster by the wind. Don't forget these brackets here. So the hardest part about these word problems is coming up with the two equations. Really concentrate, try to recognize the question type, and you should be okay. Once you set this up, the rest is just algebra. Determine the speed of the wind. Solve W. We're trying to solve W. Let's just use some basic algebra here. We're going to take this first equation and I'm going to focus on 4 times v and then 4 times negative w. So we get this equation here becomes 200 is equals to 4v minus 4w. And this equation here, using distribution, is going to be 200 is equals to 2.5v plus 2.5w. Now normally I like using elimination when these numbers are nice whole numbers and we have decimal numbers here, so I'm just going to use substitution. To use a substitution, use the opposite variable. So we're trying to solve w, so we're going to actually solve for v for one of the equations. If you use substitution, solve for the other variable, then plug this result into the other equation. So right now we're interested in solving for w, so we're going to solve for v. I'm going to look here at this formula here, and let's continue over here, and I'm going to solve for v. We'll say that 4v is equals to 200 plus 4w, because I'm taking the negative 4w and moving it over, so it changes signs. Going to divide both sides by 4, and I get v is equals to 200 plus 4w over 4. This means that v is equals to 200 divided by 4 is 50, and 4w divided by 4 is w. So this is plus w. So verify that v equals 50 plus w. So now that we know what v is, we can plug it into the other equation. And this happens to be the other equation here. So let's work with this. We're going to say that 200 is equals to 2.5v, but we know what v is. We just solved it here. V happens to be 50 plus w plus here 2.5w. So you can see that we have an equation here with only w's. We should be able to solve w, which is what the original question was asking. The rest is just algebra, just being careful. We're going to use distribution here. 2.5 times 50, this times this is 125, plus 2.5w, plus, we're just going to copy this down here, 2.5w. So what we get here is 2.5 plus 2.5 is 5w is equals to 200 minus 125. This positive 125, when we move it over, becomes a negative 125. So 200 minus 125 is 75. 75 equals 5w. We're going to divide both sides by 5, and we get w is equals to 15. So the units we're using are kilometers and hours. So w, the speed of the wind, is 15 kilometers per hour. So the key for this question is to remember this idea of resistance, wind, and how we're going to set up this equation, d equals vt, where you're going to put brackets around the velocity, where we're going to add and subtract that resistance, that wind.